In this video we're going to talk about decimal benchmarks. Benchmarks are like nice round kind of numbers that are easy to connect to. So decimal benchmarks include these kind of things. First of all, let's make a number line. And my number line starts at 0 and it goes up to 1.0. In the middle would be 1/2, which is the same as 0.5. And a quarter of the way through, 0.25. And 3/4 of the way, 0.75. These are decimal benchmarks. 0, 0.25, 0.5, 0.75, and 1.0. Those are decimal benchmarks. So if I was to say to you, I want you to tell me where 0.3 would go on this number line. Well, you can think about, what's the best place for it to go? 0.3 is smaller than 0.5, so it has to be less than that. But is it smaller than 0.25? Because this has a 25 in it, and this one just has a 3. Well, what's important is think about equivalent decimals. So if I have 0.25 and I have 0.3, what's an equivalent decimal for 0.3? Well, I could tack on a 0 at the end and have 0.30. Now I can compare. This one's 0.25, 0.30. This one is bigger, so it would probably go about here. That would probably be a good spot for that one to go. And that's how we use decimal benchmarks to help us. Let's try another one. I want you to tell me, where should 0.64 go? About where? Well, we know that it's not as big as 0.75, but is it bigger than 0.5? Well, to compare, remember decimal benchmarks. So we have 0.64. This number has up to the hundreds, tens and hundredths. And then we have 0.5, which only has tenths. So we should add a hundredths in there, a hundredths digit. What could we put in there? We could put a 0. Now we can compare and see that this one is bigger. So 0.64 would probably go somewhere around here on our number line. So by using benchmarks, 0, 0.25, 0.5, 0.75, and 1.0, we can get an understanding of where to put numbers on our number line using decimal benchmarks. Now you might be asked to compare decimals. So I want you to compare these decimals. 0.36, 0.4. What goes in this box? Greater than, less than, or equal to? Well, that's tough because this one here has 36, and this one just has 4. But remember, this only shows tenths, and this shows hundredths and tenths. So let's make an equivalent decimal. And what I mean by that is I'm going to line up the decimals like this. 0.36, 0.4. I'm going to line them up like that. The top one has ones, tenths, hundredths, place value. The bottom one has ones, tenths. So to make them equivalent, I should add a hundredths place value. What would go in this spot here? Nothing. What represents nothing? A 0. So now I can compare. Which one's bigger? 0.36 or 0.40? This one is bigger, so my symbol would look like this. Let's try another one. Let's compare 0.2 and 0.21. Well, the best thing to do when you're comparing decimals is line them up vertically. So I'm going to rewrite them. 0.2, 0.21. As long as you line up the decimals with each one, with each number, you'll be good to go. So our top number has ones, tenths. Our bottom number has ones, tenths, hundredths. It has an extra digit in the hundredths. So we should think of an equivalent decimal for 0.2. Well, an equivalent decimal for 0.2 is 0.20. And now we can compare. And it's easy to tell that this number is larger. Well done. Let's try one more example. Let's order these from smallest to biggest. 0.42, 0.5, 0.47. Alright, remember that we want to line them up vertically so we can compare. And I should always make sure to have my decimals lined up. Then I'm good to go. So as long as my decimal is lined up in each one, I'm good to go. Now, in the top example, it shows ones, tenths, and hundredths. In the bottom example, it shows ones, tenths, and hundredths. But in the middle example, 0.5, it only shows ones and tenths. So I should put something in the hundredths to make an equivalent decimal so I can compare them easier. So what should go in that spot? 0. Excellent. Now I can compare them. 0.42, 0.50, 0.47. So which is the smallest one? This one, 0.42. Which is the next smallest one? This one is 0.47. And the biggest is 0.50. If you kind of get confused, you can just look. This one has 42 after the decimal, 47 after the decimal, 50 after the decimal. And they all have tenths and hundredths, meaning they're all equivalent decimals. There we go. Have fun with that lesson, boys and girls.